Now that we've covered the three most fundamental concepts in programming, let's look at a couple of slightly more advanced topics. You've already learnt the skills to create basic programs that will work perfectly well, as you will see in the upcoming tutorials. Now we're going to cover two slightly more advanced topics: functions and object-oriented programming. To understand the importance of functions, we can liken their role to contractors building a house in the real world. We use specialised contractors such as electricians, plumbers and carpenters to complete specialised work in the real world. In this analogy, each specialised worker represents a function in programming. If later down the line there's a problem with the plumbing, you only need to call the plumber to fix the issue, not redo the entire house. This is the same as in programming. If a function breaks in programming, you only need to fix that function instead of rewriting the entire code. This modular approach ensures efficiency and reusability. In contrast, not using functions would be like trying to build a house alone, tackling every task yourself, which would be disorganised and challenging. We only need to understand the basics of object-oriented programming, which we'll cover after we've covered functions in more depth. Many developers actually prefer a function-oriented approach to programming rather than using object-oriented programming, but it's still important to understand the basics. Luckily, object-oriented programming essentially just comprises of all of the concepts that we've already learnt about put together. To complete the fundamentals of coding, we're first going to learn and apply functions, and then we're going to look into object-oriented programming and practice a couple of examples of each. Firstly, we have functions. These are my favourite topic in computer science. A function is a block of code which only runs when it's called. Instead of having one giant program, programmers generally break their code down into reusable chunks. To create a function in Python, we simply use the def keyword followed by the function name, in this case my_function. We follow the name by a pair of brackets and a colon. Under this line, in an indented block, we write the code that we want to execute when the function is called. In this case, it's these three print statements. To call a function, we simply write its name followed by brackets. As you can see, this function printed out the three statements. Hopefully you can appreciate that by writing one word on line 6, we were able to produce lots of functionality. Try creating your own simple function like this, with print statements. Now let's look at an example of a slightly more useful function. In this example, we'll create a function that calculates the area of a triangle, using half times base times height. Firstly, let's see how we do it without a function, like so. If any part of this code was wrong, the whole program would fail. Now to convert this to a function, we use the def keyword again, followed by the function name, but now in the brackets we're going to place the words base and height. These are called parameters, and they allow you to enter values into a function to change its output dynamically. Inside the function, in the indented block below, we place the same area formula as we used previously, using the base and height variables that we specified as parameters. Now when we call the function with its name triangle_area, we need to provide base and height as inputs. Let's choose 5 and 10 to be consistent with our values earlier. Saving and running the program should result in the same value as we previously worked out. So a function in programming is a lot like a recipe in baking. It needs a name to identify it. It might need ingredients, which are like parameters. In the middle, there's a method, which makes something. And at the end, it produces something. The return keyword specifies what will be output from the function, but it won't automatically print it. Try creating a function yourself for something like the area of a square. Functions like these are used all the time in programming, and we're going to see them a lot in the rest of the course. Next, let's look at object-oriented programming. We'll also be using this a lot in the course. This comprises of two main concepts: classes and objects. You can think of classes as blueprints or templates, and specific objects are created from these classes. Examples of classes include human, dog, and phone, and their respective example objects are below. Try thinking of your own class and an object that could be made from that class. Check your answer with ChatGPT. Object-oriented programming gives us a great way to model the world around us. So we know that an object is one instance of a class, which is like a blueprint. These blueprints, or classes, are used to define properties in the form of variables, and actions in the form of methods or functions. The top half of this code snippet shows how you would create a class, and the bottom half shows how you would create an object from that class. For PyGuard and most projects like this, you only need to worry about the bottom half, creating objects out of pre-made classes. This allows us to create really powerful pieces of code. As you might imagine, a team of really intelligent programmers can spend a long time building a powerful class, and all we have to do is create an object from that class to use all of its functionality. This is exactly what we'll be doing with the motion sensor and camera in PyGuard. Try creating a new dog object using a very similar command to the one on line 13, and then try and change line 16 to print out your new dog barking. In this tutorial, we learnt that functions are blocks of code which only run when they're called, and you can pass data, known as parameters, into functions. Then, we learnt that objects in Python have properties and methods, and classes are like blueprints for creating these objects. Great job completing the last two tutorials. We covered a lot of really important concepts, and if you feel like you have a better understanding of any of them, then you should be proud of yourself. Next, we're going to record audio with the Raspberry Pi.